Hello, welcome to the next session of our Monday meeting. And I'd like to introduce Professor Michelle Mello from the law school at Stanford. Her specialty in law is in health research and policy, and she does both empirical and theoretical work on the intersection of law, ethics, and public policy. And I had the pleasure of hearing her speak in Irvine about 4 weeks ago to the National Academy's Committee on Science, Technology, and Law. And she gave a really great presentation there. And I'm looking forward to her discussion today in our context here of our Center for Computational, Evolutionary and Human Genomics. Michelle.
Thanks, Dr. Feldman. I assume you all can hear me through this. Yeah, all right. Well, thanks for coming back in on a beautiful afternoon. Not that you have much choice, I assume. So, as Dr. Feldman intimated, my area is in legal and ethical issues that surround biomedical research and human subjects research more generally. And I've developed an interest in data sharing over the last few years, but in a different context to the one we'll be considering today. There's been an enormous amount of discussion about data sharing in the context of clinical trials, where we have long held data in silos and are just now beginning to appreciate what geneticists have known for at least 25 years, that there is power in large numbers and that requires an ethic of sharing. But I wanted to stick primarily with your field today and talk about where data sharing has come, why we are pursuing it as a model in genetic research and also in clinical research, and where it might be going, and what some of the barriers and challenges are that have been encountered along the way and that we're still grappling with. So to begin with, why is there so much interest in sharing data, particularly given science's orientation on personal achievement and discovery? The benefits, it's thought, of sharing information across studies are just overwhelming, to the point where even in the clinical research realm, the question now is not whether we're going to share data, but how. Particularly in the advent, a time in which we're focusing on what used to be known as personalized medicine, now, thanks to President Obama, is increasingly known as precision medicine. The mandate to pool large data sets in order to be able to accelerate the progress of this agenda, an agenda in which we can increasingly tailor clinical treatments to the particular genetic makeup of subpopulations and individual patients, is just overwhelming. And that means that we have to transcend a model in which individual sites and individual researchers are generating and analyzing only their own data, particularly if we aspire to extend this enterprise to rare diseases and rare variant associations, where it's simply impossible to look effectively for associations in small samples. A second, though related reason, though, that we might want to pool data is to assure the reproducibility of scientific research. This, too, has come under increasing discussion, large part due to the work of our own John Ioannidis, who published the provocative paper entitled Why Most Published Research Findings Are False, and launched a movement to improve the reproducibility and integrity of science across the board. It's also been a big issue in clinical research due to some highly publicized instances of drug companies and other commercial entities manipulating research findings, manipulating reports of research findings, and then subsequently being unable to reproduce or verify the veracity of those results. So by pooling data, by making them transparent and available to anyone, we empower each scientist to challenge and to verify the work of other scientists. And this, too, should accelerate the progress of science and truth discovery. It also encourages just good practice among growing scientists, because it requires not just meticulous data collection, but metadata collection, the collection of data about how a data set was compiled, study design, collection protocols, instrument protocols, and so forth, that, again, contributes to good scientific practice. And then there are cultural reasons why we might want to further encourage the move towards data sharing. It reinforces what, again, has long been an important principle in genetic research, which is this culture of openness, of cooperation, and of sharing more generally, which has numerous benefits throughout the scientific enterprise. It also has economic benefits. We can get more return for every research dollar we invest when we allow subsequent analyses, pooled analyses, to be done on data sets rather than publishing them once and then putting them away. We can ensure that there are opportunities for trainees and others to engage in low-cost yet powerful analyses, contributing to opportunities for teaching and learning. And we can, along the way, avoid losses of data that might otherwise occur as people's equipment becomes obsolete or as busy investigators move on to other interests and other projects, leaving their data on the shelf, or as they retire, allowing their data to pass into oblivion. Finally, there's an ethical reason why we should vigorously pursue data sharing, and it has to do with the altruism that underlies every genetic donation, that somebody somewhere gave that sample at some risk and inconvenience to themselves for the purpose of advancing science and probably for advancing the discovery of cures. And the more we can do with each individual data, the more we honor the donations and the active altruism of each research subject, and that is a basic ethical obligation of every researcher who works with human data to try to maximize the benefit that we obtained through putting subjects at various kinds of risks. So again, the case for data sharing, I think everyone agrees, is just overwhelming. And then the question is, how do we go about it, and how do we go about it as quickly and as responsibly as we possibly can? There have been numerous initiatives in the genetics domain that I think are worth just pausing briefly to note. Again, the history of data sharing in this domain outstrips, in terms of longevity, the history in any other field. And much of it has come from voluntary initiatives, consortia of individual researchers, supported and organized in some cases by sponsors, and extending from regional networks to now global networks. Two of the most powerful latest examples of these being the Global Alliance for Genomics and Health and the eMERGE network sponsored by NHGRI and run out of Vanderbilt. But these are but a few of the scores of private initiatives that we could list in which scientists have voluntarily come together to pool data. The other private source of rulemaking in this area has been journals. Not all journals, but certainly an increasing number, now require that the investigators seeking to publish there attest to their willingness to share data with appropriately qualified scientists. But many of the major pushes in this area have actually been public pushes, coming, for example, from the Human Genome Project. The Human Genome Project had a data sharing policy from the get-go, but the leaders of the project got together in 1996 and made a rather extraordinary pact to dramatically accelerate the pace of sharing through the so-called Bermuda Principles. Among other things, what they committed to do was to change the timeline for contributing data to a repository from the originally set 6 to 12 months to 24 hours, that they committed to put these data in an accessible database within a day. And that was not only aimed at accelerating new analyses, but also preempting patenting of human genome-related information by scientists. Once this information is in the public domain, as we call it part of the prior art in lawyerly terms, it's very much more difficult to obtain a patent on this information. So it was a safeguard against excessive patenting of knowledge, essentially, that was generated through public funds. The success of the Human Genome Project was really inspiring to others and prompted a lot greater interest in data sharing. But it also occurred before a time when there became a great deal more emphasis on human subjects protections, on issues of privacy, of informed consent. Another issue that came up since this initiative was launched was the question about how much lead time the prime mover scientists ought to be allowed to publish before those data became part of the great free-for-all of data sharing. Many of the investigators in the HGP began to assert they needed more time in order to get their publications out, and there was some recognition that this might have some merit. So in 2007, the NIH came in with a new policy that applied to GWAS data specifically, and again, these would just be things that were funded by NIH. The embargo period was very, very different under this new policy. As of 2007, what you would do is you post the data, and you could then assert an embargo or a block on further dissemination of science based on those data for a period of up to 12 months, up to the individual investigator. The 2007 policy also created dbGaP, with which I'm sure you're all familiar. And that was later expanded to permit the storage of data outside of the GWAS domain. But this really created a framework for sharing of GWAS information while promoting participant protections, because the third major element of this new policy was increasing recognition of the need to formalize some arrangements around informed consent and control access to certain data based on the rules of the consent. So what the arrangement was the individual institutions would be allowed to negotiate informed consent with subjects. When data were uploaded to this repository, they would be grouped according to the nature of the informed consent given. Some consent might be limited, for example, to studies of heart disease, while others might have given consent for their data to be used in any future research. And depending on the nature of that consent and the nature of the data sets would be placed in one of two categories. One would be full open access, essentially an uncontrolled system, and the other would be a controlled access system. And NIH then convened a series of data access committees to consider individual proposals to use these data and adjudicate whether the research aims sufficiently comported with the terms of consent and other terms of responsible use. So this was the system up until very recently. Very, very recently, in fact. In 2014, NIH again revised its policy. And so this is really hot off the presses. Just as of applications to NIH that were submitted in the January round of this year, a new set of rules apply. And they're much broader. They apply to any study that's generating large amounts of genomic data, either human or non-human. And so anyone who gets funded out of this round or later from NIH is now committing to do several things. One is to post those data in widely used repositories. So if it's human data and dbGaP, if it's non-human data, a variety of widely used repositories are acceptable. They're committing to certain timelines. For human data, they've got to be posted within 3 months after they're generated. The timeline for non-human data is a little bit more lenient. Once they're up, there's no more embargo. You can't restrict dissemination or use of those data after the time that they're posted. The free-for-all begins at 3 months. And very importantly, investigators are now committing not just to get informed consent, but to get a particular kind of informed consent. So going forward, unless the scientists can articulate a compelling reason not to, the obligation is to elicit from subjects their informed consent to the broadest possible array of uses of their data. Essentially what some ethicists might call a blanket consent for future research, saying, I consent to give these data, these samples, biospecimens, genomes, for whatever research purposes an IRB might see fit to approve in the future. So this is really a significant change, and the reach is also very significantly greater in the past. This informed consent requirement reaches into areas that we didn't traditionally think about as having to get informed consent in, like dead people. And really imposes a new regime for how we think about informed consent for these samples. So this is the world that we're now entering into as far as NIH-funded research is concerned. So how should we think about the risks and promise of this new era? Well, in terms of risks and concerns that data sharing raises, there are several that are really noteworthy. From a scientific perspective, there has been grumbling about the risk of drawing spurious conclusions based on type 1 error when we're dealing with samples of this size. This is a common refrain in all conversations about creating large data sets. But more seriously, there are sort of logistical and ethical concerns that have to be dealt with. And one is the very real burden that data sharing poses on researchers. In an era in which investigators report spending onerous amounts of time just complying with NIH administrative requirements and other paperwork and administrative requirements of being a PI, this is yet another requirement that has to be built into indirect costs and somehow found in the busy lives of scientists to comply with. There's also real burdens around generating the metadata and documenting it in a way that others can follow. These concerns are of moderate severity for genetics, much greater severity in the realm of clinical research, where there's a lot less standardization around how things are done, and a lot more that would have to be explained in order for somebody to be able to pick these data sets up and use them. And then there are real significant incentives problems. The data sharing poses what we might consider to be a classic collective action problem. A collective action problem is a situation in which what is socially optimal, what is best for us as a polity, is not what is best for each of us individually. And in the case of data sharing, the best possible scenario is everybody else contributes their data, which you may access, but you need not contribute yours. When we have a problem like this, where free riding is a potential possibility, it's a classic situation where regulatory requirements are often brought in. If everybody has to do it, we level the playing field and we eliminate free riding, or at least we allow everyone to free ride the same amount. But there are some additional concerns here that go beyond just a regulatory requirement that everybody participate. One is, what do we do about the potential loss of patent rights? And again, this is a concern both in the clinical domain and in the genetics domain. So again, once these data become public, it's much harder to make the case that you deserve a patent on them because they're in the public domain. So regardless of whether we make it fair in terms of everybody participating equally, some will lose more than others because they will lose out on intellectual property rights. There's also the potential to lose out on your right of priority to engage in subsequent analyses. So you can get that first paper published, but what about after that? After that, you've got to just be faster than the competition because you've now lost your property right in the data to be first on subsequent publications. Good for science, bad for you. Then there are issues around appropriately acknowledging those who contribute data to repositories. There are evolving standards in this direction, but I would say not yet a consensus about, for example, when somebody's contribution to a large data repository merits co-authorship. What kind of co-authorship? How significant does the input into the scientific research have to be in order for co-authorship to be acknowledged? And if we're not going to give everybody co-authorship, what other forms of recognition could be offered in order to allow scientists appropriate recognition for their contribution? There are several other methods, but as these have been tried in db-GAP, the compliance has been less than optimal. For example, you are supposed to cite the accession number of each piece of data that you're using in your papers, and you're supposed to include an appropriate attribution notice, but when they've gone through and looked at these, they find that often scientists don't comply with that, and journals are not generally in the business of ascertaining whether those have been complied with. All of this may also contribute to reduced incentives to collect primary data. So the more powerful and exciting the available secondary data become, the more we have to ask ourselves why go to the trouble and expense of securing funding and carrying out very resource-intensive primary data collection. So in the aggregate, we may be reducing the amount of data that are discovered at the same time that we're expanding the extent to which each individual piece of data is used. Non-participation by commercial entities is another concern. So we've been talking about free riding, but one of the major distinctions that occurs in terms of participation is, are you an academic institution or are you a for-profit company? For-profit companies have been disproportionately reluctant to jump in and participate in data sharing initiatives, and understandably so. This is their livelihood. The company that has had the most focus in recent years has been Myriad Genetics, the BRCA gene testing company, that they have been involved in patent litigation that's gone all the way up to the US Supreme Court, and most recently have just refused to open up their genomic databases for broader study, although they are happy to give individual subjects the right to upload their own data. This is their sort of proffered solution. They've accumulated this massive amount of BRCA data, and many in the field have been frustrated that this is not being shared. At the same time, though, in this particular case, that reluctance to participate has actually spurred others to try to compete with their database. So the Genetic Alliance, for example, has issued the BRCA Challenge to try to challenge non-commercial entities to build a database of BRCA data that would rival Myriad's. Lack of harmonization of standards internationally is a major barrier going forward, and there are two domains here. One is ethics standards. So individual countries really vary in how they approach the governance, particularly of human subjects research. When do you need to get IRB review? How is that done? And what are the substantive standards that are applied in terms of privacy protections and informed consent processes? Some of these are matters of law, so they're sticky, they're hard to change. And at present, there's a situation in which, depending on the data set, you may have to shop around to IRBs in dozens of different sites and even different countries in order to be able to use pooled data. The other aspect of it is international variation in technical standards. There's convergence here due to a lot of concerted effort to try to generate standards and formats and processes that all can follow, but there's still quite a bit of variation that really makes it more difficult to pool data. And then finally, on the human subjects protections front, the issues are legion, and I'm just going to sort of distill down the big three here. The first has to do with privacy. This has been extensively studied, primarily in the context of biobanking, the use of biospecimens, whether the genomics are attached to the research or not. But here's what we know. Research participants are really very highly willing to donate to biobanks and other repositories for research purposes. They're highly motivated by altruism, even among those who are currently sick and seeking cures. Their impulse to be altruistic is high. But at the same time, they remain very concerned about the potential consequences of a breach of data security or confidentiality, particularly with respect to their genetic information. Now, we have passed laws in this country to protect against genetic discrimination. As early as the 1990s, we passed initial state laws that tried to prevent this, but the big progress came in 2008 with the advent of the Federal Genetic Information Non-Discrimination Act, which barred employers and health insurers from discriminating on the basis of a person's genetic test results or genetic conditions. Soon after that, in the Affordable Care Act of 2010, the protection was extended to prevent health insurers from charging more or denying coverage on the basis of a pre-existing condition, including a genetic condition or predisposition. So at this point, the legal protections are actually fairly robust. But there's a great deal of uncertainty among patients and research subjects about the extent of these protections, and that's probably reasonable because it takes a lot of effort to litigate these rights and vindicate them in the courts. So they remain concerned that genetic discrimination might go on below the table in ways that are hard to detect and rectify through the courts. And as a result, they're very much concerned about being assured that their privacy is protected in the context of genetic research. At the same time that these concerns have been increasingly percolating, we've seen several papers come out that, for lack of a better word, have hacked large repositories of genetic information and really demonstrated that there's no such thing as completely de-identified data in this day and age, that with sufficiently sophisticated statistical methods and triangulation of data from multiple sources, including the voluminous sources of information that are freely available on the internet and from genealogy companies, it's possible to re-identify individual subjects with a surprisingly few number of data points. So this has really blown up the notion that by stripping away what we commonly conceive of as identifiers, we're sufficiently protecting participant privacy. And that, in turn, calls into question whether a model of uncontrolled access to data is viable, or whether we need to move virtually everything into the domain of controlled access, where there is a star chamber, a committee of some kind, that's going to be reviewing each and every request for data for what? For scientific validity, perhaps, for privacy protections, for adequacy of informed consent, for potentially the scientific value of the research, perhaps the extent to which the research disadvantages commercial entities or is unfair to other scientists. The standards are relatively unclear. In the clinical research domain, there's lots of attempts to layer on all kinds of criteria in order to have strong gatekeepers. And this is largely driven by the dominance of drug companies in this space. They want to be sure that whoever gets a hold of their data deals with it responsibly, is appropriately qualified, and is not going to develop junk science that slams their products and scares consumers. These issues are less present in the genetic domain, and I think there's greater trust among the scientific community in their qualifications and the ability to produce good science. But nonetheless, these concerns about privacy raise a fundamental question of, are we going to empower somebody to control decisions about data release? Who is that somebody? How did they get vested with the power, and what decision criteria do they apply? The second of the big three human subjects issues is eliciting informed consent here. And a number of events have really focused attention on this in new ways. One is the publication of these papers demonstrating our ability to re-identify individual participants, with the notion now being if you can't promise protection for privacy, you better get consent to a potential breach. And then there's been a series of lawsuits that have really brought to the fore the implications of some of these breaches. There were 2 lawsuits against state governments in Texas and later in Minnesota that were operating mandatory newborn screening programs in hospitals, and then without parental consent using those de-identified newborn spots for research purposes. Very powerful data set, lots of good came of it. Nevertheless, a group of parents became very incensed that they hadn't been allowed to give consent for the research use of the data. And after much negative publicity, the case settled, and the state of Texas, for one, had to destroy 5 million newborn spots and the data accompanying them. In 2010, there was another highly publicized lawsuit, this one brought against Arizona State University researchers by the Havasupai Indian tribe. Arizona State had developed this partnership with the Havasupai to study diabetes, which was endemic in their population. And they had engaged in an extensive process of community consultation leading up to the research, in which it was explained that they would be focusing on diabetes and that this would be a great benefit to the population. The consent form was a blanket consent. It actually was very broad and gave consent for use in all kinds of future research, but that hadn't been the focus of the community consultation. After the initial diabetes studies were published, some other researchers at ASU became interested in using these data for all kinds of other purposes. And the tribe wasn't very happy about some of these purposes when they were published. One was a study of the link between Native American ancestry and serious mental illness, including schizophrenia, a stigmatizing condition. And another was a piece of ancestral research that demonstrated that the tribe's own origin story of where its people came from was, as a scientific matter, incorrect, that they were not indigenous to Arizona, but rather had migrated across the Bering Strait. Again, deeply offensive culturally to these people. There was a suit which alleged a breach of informed consent. It was an expensive suit settled by Arizona State. And really a cautionary tale to researchers that the informed consent form may say one thing, but the understandings that people may have about the uses of the data may be quite different. And that, in turn, really raises the question of whether broad consent is really consent at all. When people like the Havasupai sit down and think about what am I agreeing to when they sign a blanket consent, do they imagine the potential uses of the data and all of the ways in which it may offend them? There are other reasons why obtaining meaningful informed consent is really tough in the context of genomic research. One obvious reason is just the complexity of the scientific information that has to be conveyed. And the standard for consent forms, as you may know, is that we have to convey this at an 8th grade reading level. Not easy to do. And the other complexity is just the unpredictability at this rapidly accelerating field of where the research may go in the future. So if we move away from a blanket consent approach and try to describe different kinds of research, for example, how do we do that? How do we get that right? There are a number of approaches to informed consent that have cued off a growing body of research about what people want. So one thing we know for sure is people want this research to succeed. They want to see the growth of big data in genomics. They understand its power and they're willing to participate. But their willingness and their trust really depends on who's using the data. There are lots of people who are willing to consent to use it by all of you, but as soon as you go down the street and start working for a private biotechnology company and begin to profit off those data, they'll withdraw their consent and their trust. The biggest problem, though, is the finding that almost everybody is quite happy with a blanket consent, but 10 to 20% of the population wants to be asked about each new use of this data. What do you do with this? It's okay with most people. You know, ethics standards don't generally bow to the will of the majority, but recognize the right of each subject to maximize his or her own welfare, make his or her own decision. So that these kind of findings make it really hard to generalize a policy when we've got variation in the population in terms of what they want. And then finally, we know people have really poor recall of what they consent to. Perhaps because we're now into the territory of informed consent forms that are 15, 20 pages long. Studies have found that like 25% of people don't recall that they're in a genetic study at all, don't remember signing the consent form, and certainly don't recall who they agreed to share their data with. And the implication of this is we can get surprised down the line with complaints and litigation because people don't recall these detailed decisions that they made. So how do we get around these problems? How do we grapple with them? A number of approaches have been proposed. The blanket consent one is the way that NIH is now going, as we've talked about. IRBs, on the other hand, have been hewing closer to the second approach here, tiered consent, which is an approach that says at the end of your consent form, give subjects 3 options about future use of their data. Either don't use it for anything you want, or use it for only these specific things, other heart disease studies, other diabetes studies. And IRBs have been thinking for years this sort of gives people the maximum amount of choice while creating a default option that most people will choose of blanket consent. But there are some real operational problems with dealing with that in the data sharing context when we've got so much complexity around who consented to what. The newest model that's advocated by a lot of patient groups is dynamic consent. These patients say, look, why are we operating on the assumption that the only touch you're going to have with me is when you take my blood? We're in the internet age. You know where to reach me. I'm a highly empowered consumer. I wouldn't be in this research in the first place. If you want to use my sample again in the future, email me, and I'll tell you. Or create a website where I can go on and tell you in a dynamic way, an ongoing way, what I want my samples to be used for. The counterpoint is, of course, this creates additional burdens on researchers and also gives rise to more selection bias as people opt out for various reasons. And then finally, there's a group of ethicists who really say, look, we've been emphasizing informed consent too much. We have to put more emphasis on community consultation and building partnerships with subject populations because we know people's preferences around this are not well informed. We know they tend to forget and get mad later. So we should focus on developing understandings in communities of the general directions in which genetic research is proceeding and what the benefits are. The third of the big problems, and the last one, is how to return incidental findings to subjects, or whether to return incidental findings. So suppose you're combing through a data set that has some identifiers attached, and you discover something that is clinically relevant to that patient. Or if not clinically relevant in the sense that there's something they can do to ameliorate or prevent a condition, might be very relevant to their life plans. Do you have an obligation to return that finding to individual subjects? And how does that obligation change as the data go into a data sharing repository and are used 10, 20 years in the future by people all over the world? We know empirically patients want all this information. They want all kinds of incidental findings, genomic, non-genomic, stuff they can do something about, some stuff they can't do something about that might affect the way they think about their lives. When ethicists have taken on this issue, they've tended to distinguish between stuff you can do something about and stuff that you can't, and also genetic data that is highly predictive and not highly predictive, that it has a considerable element of uncertainty. But that's not how patients tend to think about it. Ethicists also acknowledge that returning incidental findings can involve emotional harms for patients. This is, in some cases, devastating news. And there are questions around what your obligations are. If you decide to return the information, what else do you have to do for the person? And there's also recognition that even some clinicians don't know what to do with genetic information that's returned to them. The literacy of the everyday primary care provider around use of some of these genetic information, genetic markers, is really low. And so again, the question is, what else do you have to do besides provide the information? How do you help to gain literacy and the ability to respond clinically to some of these findings? We also know, on the other hand, that not returning incidental findings can really affect the trust that people have, not just in the individual research team, but in research institutions generally, and therefore in our ability to conduct this kind of science in the future. While traditionally in research contexts that are separate from clinical care, the obligation to return these kind of findings has been very, very limited. The question now is that going to continue to be the case in an era where more and more of this information is recognized as clinically useful? As our knowledge of what to do with all this genetic information improves, how are we going to reconsider our obligations in this domain? So these are some of the big sort of challenges or barriers that the field has been grappling with. To close things out, let's talk about what we might need to do to move things forward in the future here. I think one of the big issues is simply technical, that there's been enormous and incredible progress made in finding new informatics with which to analyze and store these data. And the advent of cloud computing just opens up the possibilities dramatically. But the volume and complexity of the data are keeping pace with the development of these new techniques. And so we're going to have to continue to find ways to grapple with just the enormous volume of information that's being generated. The second major challenge for the field, I think, is figuring out how to bring the genomic and the clinical data together in a way that is useful. In many research contexts, these continue to be siloed, and this has prevented some problems, again, because a lot of clinicians don't know what to do with the information. But with this push towards precision medicine, there's also going to be a push towards integration and figuring out, for example, how to merge data from the clinical electronic health record with genomic data for research purposes, and then also how to re-embed genomic information back into electronic health records so that clinicians can get it and figure out what to do with it. There have been a couple of important initiatives emerging to try to tackle these problems, such as the eMERGE project out of Vanderbilt. But it's really still in its infancy, and it's really hampered by the fact that electronic health records are really, really heterogeneous. There's very little interoperability across systems, and so it's sort of death by 1,000 paper cuts trying to figure out how to stitch all this stuff together. I think a third major challenge for the field is reaching international consensus on these informed consent issues. That we have to probably think about a new model of governance. Instead of devolving this responsibility to individual institutions, as NIH has historically done, we need to sort of elevate it to the international stage and come to some kind of international agreement about how we're going to seek informed consent and how we're going to govern that process. And then finally, there's a sort of cultural question about whether the classic model of science in which we are all aiming to be superstars and generate groundbreaking discoveries is consonant with the vision of data sharing, which is intense team science, global team science. So to leave you with some of the issues to sort of ponder and discuss in the Q&A, I think one question we're going to have to answer as a polity is whether it's time to reconceptualize the use of anonymized data. This has been the traditional out for a lot of the human subjects problems raised by data sharing is let's just strip out all the identifiers. Now it's not human subject research. Now we evade review by IRBs. The government has nothing to say about it. But in an era in which we have to acknowledge there's no such thing as truly de-identified data, it may be time to jettison our preference for anonymized data because there's an enormous scientific loss associated with that, particularly in the era when we're trying to link up to clinical data. So let's get rid of this model where we're focusing on anonymized data and think about a humane and responsible system for sharing data that do have some identifiers attached. The second is how do we get research in the clinical domain to get where you are now? The norms in that domain are radically different. There has never been this ethic of sharing. There's been this dominance by commercial entities. Drug companies provide 70% of the funding for drug trials, drug and device trials in the United States. And so there's much less of a feeling that this is knowledge that is paid for with public funds and belongs in the public domain. Much more concern about patentability, concerns about regulation by the FDA, which might be adversely affected by junk science. Lots and lots of barriers. So whatever the barriers are in the genetics domain, they're tenfold in the clinical domain. And the question is, are there lessons from genetics that we can apply in that domain? And then finally, what do we do about the organization of science itself and the state of science? Is this vision of global sharing just out of step with the realities of being in science today, with the intense pressure to compete for funding, the intense pressures around promotion, getting academic positions? How do we create incentives and reward and recognition mechanisms that encourage people to contribute to a team model when they're facing those realities in their everyday lives? I imagine that's the issue that's most germane to many of you as you think about your own role in data sharing. So I'm going to pause there. We have a little bit of time for questions. Thanks.
Questions? Carlos.
I'll throw out a question, right? So one model could be that in 20 years, departments of genetics are going to look more like economics departments today with a national paper bureau that organizes the data and makes it available for people to reanalyze, right? Where the linked electronic health records and all the associated data are basically bundled in a way that track the most meaning out of it. The other model, which is, I like to tell people, if you read that great paper on 1 million MRIs last week in Nature, people go, oh, really? I must have missed it. I'm like, no, of course not. There was no 1 million MRI person paper. People don't share MRI data, right? And so it just gets siloed and it sucks. So can you speak to those sort of two worlds and which one you think are most likely to end up happening, and maybe in the U.S. versus in the UK or in other places where biobanks and national health care may be seen as something we all contribute to, and so it's sort of our duty as citizens to share the data so that we can all.
Yeah, I mean, I think you guys, from speaking from within the culture of genetics, are probably much better positioned to answer that question than I am. But I would say probably economists would quibble a little bit with that characterization of their discipline, that there is this ethic of transparency within economics, for sure. But there isn't, most places don't have a superstructure that, for example, standardizes how fields are described, creates data dictionaries for investigators, maintains a server where this is all posted. Not to mention that these are the simplest possible data sets that one could imagine, very clean. So the sort of, the complexity is just an order of magnitude greater, and I think the field of economics is committed to transparency, but not the systems, building the systems that it takes to get there. So I don't see that as a model that we can learn a great deal from, other than the presumption that one ought to be transparent. But neither do I think we can swing all the way to the other end of the continuum and have continued siloing. That just doesn't seem feasible. There's got to be a third path, but I don't think either one of those polls probably represents it.
Okay, Professor Mello has to dash off. Thanks very much.